Gadget UK here again, back for part 3 of the GBA 1000 build. Massive thanks to Conrad for sending this PCB. So just like the previous part, there's a few montage parts throughout this as we sort of speedily rush through building this. There's quite a lot of components to go on it. And I've just sort of stopped and highlighted where I've got particular problems, and there are a number of issues as I actually work my way through building this. I would like to just work out what these are. Now this is the difficulty of this thing. Trying to test a component like that, you've got to press the button and then put the probes on. Look, it looks like I broke it off. I haven't. It goes into the little thing there. It's a little like pin fitting. I can't get in. Right, there we go. Let's try again. Oh, this is going to be difficult, isn't it? You cannot clip these clips onto that. That's for sure. So like, I'm going to quickly just try and press them. Hang on, against each other. It says, and oh, hang on, it flew off then. Let's try again. Analysing. There we go, it's 100 nanofarad. It's incredible how long it took me to measure. So yeah, those are 100 nanofarad, so I will do what I always do. And this is my suggestion to you. If you don't keep things in bags or drawers for individual components and trying to keep a load of these in an individual drawer where there's like 10 million sizes of them, well, you're never going to do that, are you? And bags, well, that's a good thing, but they take tons of space. So I'll actually write on this 100 nanofarad. And these are 50 volt, by the way, 50 volt, because I remember ordering them. Yeah, I'll do the same on the other strip. Anyway, you get the idea. So we haven't got very many of these to fit on, actually. Maybe 20 or 30. There's only several on the underside, but there might be a load more on the top side, so I'll report back when we've done some of those. Yeah, and if you hadn't spotted, that socket was round the wrong way. Pin 1 marking was on this side. It's actually that side, so I've just dissolved it. You can argue that is the most ridiculous thing ever, because it's not a big deal, but it's, well, it's just something that was bugging me, so flipped it back round the right way. So as you can see, quite a lot of progress. So yeah, I've been skirting over this. I did say at the beginning it should be highlights and things. I've covered it all so many times in so many different videos, so many builds. If you look at any of the build videos I've done of mods and upgrades and things, it's all the same stuff really. So I'm waiting for CPU socket, coprocessor socket, a load of gals. I've got to try and work out how to program the chip that goes here. I thought my TL866 would do that, but it doesn't, so I'm going to need to check. I think maybe the program will do it at Willem, but I'm not sure how to wire it up. That's the issue there. You can see I fitted all of the 47 microfarad tantalum, some 10s, and that's a 10, that's a 10. 47s in a number of places. The design of this does, the BOM does specify tantalums, but I've put electrolytics on as well. We've got 3 there, 1 there, 2 up there. The ones on the audio section here, they're supposed to be like bipolars, but I've gone with polarized electrolytics. The same way that all of the Amigas originally shipped with, but ultimately I might swap those out for something else at some point, and the polarities in such a way that, the right way around, the negative side is going to the output, because those are the coupling caps as far as I can understand, following the traces up here. That one is obviously an electrolytic as well, and short of 5 or 6 capacitors on here still, and I've ordered those, the 220 microfarad. There's still 2 47s to go on as well. I think there might be a 47 in each of those places there, maybe, or something like that. So I need to get 2 more tantalums for those 47s. That's what I'm going to do. 47s I've generally stuck with tantalums, apart from 1 here I think and 1 down here. I've also got a couple of ceramics there doing coupling at 22 microfarads. So again, I might change those, but the design actually does specify ceramics there. They're a bit smaller than perhaps the footprint size, but anyway, those should do the job. Yeah, so it's come along a long way. I've spent so long on this, I can't emphasise how many hours really. It's like every day I've spent 2-3 hours or more where time is permitted. So I still need to solder the sockets on the amber here. I'm kind of reluctant to do that just now. I might leave the amber stuff, because what I'm thinking is, if I'm going to prototype, try and reverse amber, it would make sense to have pin header here, and then I can plug a little module in, rather than try and deal with some sort of plug-in PGA style thing. I don't know. I'll have a think about that. because I do know a few people have created like a 3D printed bung that you can use with pins and actually stick something in there. I might go that route because that might make sense, and we've got enough space up here to plug a board in and overhang it, maybe this way like that, or something over this area, or that area, because the chips here are going to stand up just the same height as that. As long as it's stood up sufficiently high, I could have a PCB that way or a PCB that way, and a PCB is going to be needed, I think, just to add a few more 7.4 series. Ultimately, I might be able to get something that will fit in the profile there, but anyway, that's a long way down the road yet. Still need to solder a majority of the solder points there as well, and I think one of the CIAs is not properly soldered on, if I remember. Maybe I'm wrong. Now they're both soldered on. Yeah, there's some of these things here, those are anchored on those two, but they're not soldered. But I'm waiting for some more dip sockets as well. And of course, more dip sockets for all of these things. But I've shied away from sticking things next to where there's resistors, and I'll show you. I've got all of these resistors here to fit still. So I've got a load there and a load here, and I'm still waiting for some 4K7s, I think. So the 4K7s are not going to be melts like these. These are all high precision, 1%, every one of them are 1%, the resistors have fitted so far. Just with the, as I mentioned earlier, with the intention of getting really tight on the, accuracy on the video and audio section. The 4K7s are going to be mostly pull-ups, so it's not really a problem that those are going to be just ceramic ones, but there's going to be a mixture of things on here. And the other interesting thing with this build is it's an accumulation of everything related to my channel, really. So what I mean is, these tantalums, these came from Cather's machine. We removed these when we recapped it, and some of the other caps went in the bin because they were awful, but the 47s were all alright, so I've used those on here because that's what it specified. But generally speaking, is it a really good idea to have tantalums on a board like this? I don't know. Ultimately one of them's probably going to short, but they measure okay. I've ESR tested them, but ultimately one day one of these may come back to haunt me. But I've used odds and ends from lots of different builds on my channel. There's the odd resistor, the odd cap, well, the odd cap actually. The 100 nanofarads were used on other things, Archimedes and things like that. So yeah, there's surplus components from things like that. Some of the sockets and things came from Alice and Chalice's stuff. We've got the original cap and crystal here from the 500 plus board. Obviously the connectors from a 500 plus board, that came from a C64 we salvaged in the past. So there's lots of bits that have come from other videos, kind of thing, other areas of my channel. Transistors from the original 500 plus board. Obviously took off the real-time clock from the 500 plus, and I've taken off the 1488 and the 1489, which go back here. So I'm probably going to need turn pin sockets for those because the pins are a bit short, but I want to try and use those original ICs. Anyway, I'm going to have a go at fitting some of these, so I'll show you one or two of these. Right, so more parts have arrived. I have just removed two sockets that I've pinned. I pinned these sockets here, and I fitted those. They're going to be alright. I've got some aluminium foil over there. That was something that someone suggested on the previous video, 600 one actually. And then get some Captain tape over that, and then we should have, when that one's not there, we should have enough space around here. And again, I'll protect some of these things. We should have enough space to mount those with hot air. That's what we're going to need to do. Tin the pads, put the chip on and flux, and then heat till it sinks down, and do that all the way along. So yeah, that's why I removed those two. But more or less every socket is on there. We're just a few sockets short, and I'm not fitting these ones or that one until I've got all these resistors and things around here, because it just make it really fiddly to do. So another order, got the audio chip there, the LM op amp. We've got, in fact that's for something else, it's the same type of RAM actually, I think 54100. So in theory I could fit that there, but actually that's for the A570, which you haven't seen. It came from Sparks UK, bought that. Just finished paying off that this month actually. And then we got some more of these little or is it SOIC devices. I think it's a 7.4. So I don't know where that goes, on the underside I think, because I don't see a footprint for that here. And then a load of capacitors here, so we're just waiting for some to be sent separately. Oh, there's a few to be sent separately actually. But anyway, hopefully I'm going to have enough components here to almost finish this off. We've got 3 different types in there. We've got, yeah, 5 meg 6. Look how many I've got, 100. I want one. I couldn't find them anywhere else that was pretty affordable. This place was cheap, it was like a couple of quid or something for 100. And I figure that's probably the best route to go. But when I'm ever going to use 99 5M6 resistors, and the 1% ones as well, which is really cool. That is just what I need. Because I think that's something to do. I think that's something to do with the PLL stuff around here. It might not be. It could be something further up. But anyway, 1% is good. I like 1%. And I didn't actually intentionally order 1%, I just ended up with 1%. And then there's a resistor that I couldn't work out. I've got 91 ohm. Now there's a bit of this, and this is the thing where if you're building one of these, if you want to build one, or if you're about to build one, you've got the parts and you've been putting it off, these things can just help you out. There are a few places where, I'm trying to find it now, the parts are a bit cryptic. Let me just see if I can find it. Oh, here, yeah, so I'm getting confused. Oh, in fact, there's 2, look here, 330 and 332. So you're like, 332? Why have we got 332? It's a typo. You meant to put a 0 there. It means 33 ohm 2, yeah? And in fact, it's not. It's 330 ohm, that, I think. And that's what I fitted. I put 330 there. That might not be. It might be 33. It could be 3.3K. I don't know, but I went with another 330 ohm, assuming the last digit was just wrong. And then here you can see 33 ohms, yeah, and then you've got 33R2. So I was like, does that mean 33.2 ohms? That's ridiculous. Try and find a 33.2 ohm. No, it's not. I think it's just more 33s. So there's a few things like that on here, and there's one there, look, 3K32. That's just under the 3K3. In fact, there are no other 3K3s, I don't think. So yeah, anyway, there's that, but then the resistor I'm just dealing with here is the one with the 9. I'll try and find where that is. It's on the last page, isn't it? Wherever the last page is. I seem to have lost a page somewhere. There it is. 90 R9. Does that mean 90.9 ohms? What does that mean? Anyway, the nearest I could get was 91 ohm, 1%, so that's what I've gone with. Yeah, there are some other differences here, and I'll perhaps mention those when I remember them. Anyway, I'll show you 1 or 2 of these. Obviously these are the, you know, square, rectangular, not square, rectangular type things, you know, little chip type ones rather than MILFs. But there's very few to actually fit. It's like, you know, 1 5M6, 1 91. There's just the odd space and the odd place to fit those, so it's not really a big deal. Yeah, and actually the 5M6 is around the real-time clock area. It looks machine assembled in places. Alright, granted, when you're up close like this, 1 or 2 things look a bit crooked. There's a bit of solder there, not bothered, because we're going to get something on that. Anyway, that's 1 down. And just 1 or 2 components here. This one is an example. I've had to get an approximate value as well. So the 91 ohm we've fitted, and that went on the PLL circuit. This is the real-time clock section. We fitted the 5 meg 6 there. The one in the middle here, 20 picofarad. I couldn't get 22s. I know what this is just the other cap for the loading of the crystal here. Yeah, in fact you can see the connection. You've got the 5 meg 6 going to one pad, but it comes down from that cap as well, and then the other side of this is going to go to the variable cap there. So that will be fine. Yeah, and I had to just go check the schematics yet again to see where R78 was. I was thinking it was up here, and it is. So I found that, you know, this is the video, the 23-way D connector. and it goes here. It's another 4K7. You've got V-Sync and H-Sync go here, but that took ages to work out. I must have spent 10 minutes trying to find that location on the board there. Yeah, I literally just barely touched that. It's just there on the edge. I think if I flatten that, you never know. Yeah, so you can see nothing. There's literally no mark there. There's more of a mark here where I haven't touched it, where it had some damage where it was on the original board. So yeah, that's not a big deal. Anyway, that's one more down. Yeah, so filming this for my own benefit more than anything, in case I need to refer back, is that R113? I don't know, it looks like it, doesn't it? I've tried to find it on the schematics, it doesn't appear on the schematics. It needs to be 4K7. I think it's that one, I don't know. What else could that be? 123, 128, 12... It's got to be 113, I don't know. Cheesing me off, this board. And here's a quick tip for you: when you get down to the last, I don't know, 20% of components, it's actually easier to find a spot on the board, e.g. R120, check the components you're dealing with and go, ah, that's one of them. Yeah. Because all I've got left really in terms of resistors is pull-ups. I think there might just be one size that I'm still waiting for, but I don't think so. So anyway, yeah, I found that one really easy, and I may do that with the next ones. It's far easier than trying to find, you know, getting the number off the bill of materials and then trying to find where it is on the board. If I get solder on one or two of these wires, it's not a problem. Just, you know, they end up just a bit tinned, like that one just got a bit tinned. It's not a big deal. And I've deliberately done that around any of the electrolytics, as I said I would. I will toothbrush around these areas that you've seen me soldering these resistors on later. I think that's 114. I'm not going to check on the schematics because I'm fairly convinced that's a 1 and a 1. As you're working your way through a board like this, it gets a bit easier. So, like, trying to find C100 here. Well, these 100 picofarad caps, they're all on connectors. So, like, there were 3 of these on each of the mouse joystick ports, and then we did 2 here on the keyboard interface. And I couldn't find C100. I thought it's going to be on the keyboard, and I went back to the keyboard. I went, ah, there it is. And when you get like 4K7 resistors, well, they're going to be pull-ups, so they're going to be on digital connections. They're not going to be on the op-amp or scan doubler section unless it's a pull-up somewhere on the logic there. So yeah, you can make some sort of educated guesses as you're going along, and that can just help speed up the process of trying to find the relevant place for a component. Nearly done with all of the components I've got to hand again. So then I'm just waiting for the last few sizes of caps, I think, for the primarily for the audio, and obviously some smoothing caps. There's not quite enough solder there, I don't think, for my liking. Yeah, I need the 220 microfarads to arrive. There we go. Yeah, and another one of these notes to self that we may need to revisit together, and that's C117. It's not fitted, and I was like, what's C117? And I just looked at the BOM. It's supposed to be 100 nanofarad. Now, I ticked off C1117, which makes me think that I've mistaken that for one of the caps on the underside of the board somewhere, the one where you can hardly read it. And this is the thing, you know, when you can't read the print, it's really easy to get the wrong. Hang on, I've got 2 out there then. It's easy to get the wrong component in the wrong place. So I don't know whether I've fitted, you know, something in a crazy place where it needs a very specific size, like underneath the scan doubler circuit or something, or I don't know. So that is a little bit of a concern. Anyway, so we're now fitting C117 again. Where the other 117 is, I don't know. This is why I don't really have a high level of confidence in this, hang on, where's it gone now? This project working at the end. There's that many variables in terms of, you know, not very clear silk screen, so many gals and things to program, and the main CPLD. I don't even know whether I'm going to be able to program that CPLD yet. I can't get the tweezers at the right angle. That'll do, it's fairly straight, I think. Yeah, so I feel tempted to go and have a look now to see if I can see another, what looks like C117 somewhere. There might be something like that underneath around where Agnes is, because I saw something around there, that area of the board, because I just vaguely remember on the underside there's a few caps there that you can't actually see what they are. It might be supposed to be 47 something, like a picofarad one, rather than nanofarad. I'm not bothered if that via gets covered there, I just want to, there we go, just reflow that, that'll do. Yeah, like one or two of the clocks may have a cap on, and well, if you've put 100 nanofarad on a clock, strange things may happen as you considerably alter the edge and affect timing. So I do need to go check, and that's the thing, that could take me forever to try and work out. If it doesn't boot, you know, and I just don't get anything, or some really weird behaviour, I'm like, well, how am I going to resolve that? It might be easy to resolve if it's something obvious, like, you know, a main clock doesn't look right, or isn't the right frequency, but it's not going to make that kind of adjustment. It's just going to mean that things don't fall on the right edge. I need another cotton, but it's looking a bit glossy. That's what happens with this flux when you don't get it all up. Yeah, so we've got one original floppy drive connector there from a 500 plus. These Molex connectors, which are exactly the same, minus the fact that these have got like a little lip there, a lump. Yeah, so when the connector slides down, it pushes the back out, and there's no hole on the back to correspond with a little notch there. So I pulled the pins out, drilled a hole, smoothed it down, and then filed down the notch there, put the pins back in, and as you can see, it looks nothing like that one. The pins are nice and straight, but the net result is you can plug one of these on and it sits perfectly flat and clips in there to the hole in the back. So yeah, it was a bit fiddly, and of course I could have just bought one, but well, I couldn't find one. I'm sure there's a name for it. It's Molex, but it's the certain, you know, it's like a custom version of Molex. It's got that little gap in the back. You could argue it's a, you know, I don't know, a locking Molex or something like that. Honestly don't know. Post down below if you know exactly what it's called. Yeah, anyway, the pins are nice and straight there. Right, I've soldered that connector on. It works perfectly. I'll show you. Plug that into there. Grips perfectly. Yeah, so that will do me. It's homemade connector. Anyway, let's get the 74F245s on. So we've got two of these here for the RAM by the looks of things. Well, they might not be, but they're right next to the RAM, so yeah, so it's where they are. Yeah, so I'll swap over to Cavados Cam and we'll get those two on. And there's also, I think, a 74F74 wants to go on the underside. We'll do that as well. Yeah, so a little bit of micro adjusting. Hang on, it's probably easy just to use my fingers here at this stage, just to try and get that equidistant. Yeah, I tend to fuss over these things more than I perhaps should. And it's probably going to move in a minute. Anyway, I'm going to record this and you can see it in real time as well, you know, actually captured from the microscope. So I'm going to, I can't really see the edge of the board here. Oh yeah, this is the problem, see. Let me just zoom out a little bit. And probably the best thing to do is not fuss too much, just anchor it. If it does move, just don't worry, just anchor it on the one pin. Like that. And if you need to move it, but I don't know, I'm pretty happy with that, to be honest. I mean, you can argue there's slightly more of a gap here than there is up there, just marginally. So I mean, I could just press just like that and then reflow. Yeah, that's alright. So we'll just come in up here, just making sure I've got pin 1 the right way. Yeah, I have. And again, I can't see where I am. There we go, anchored it there as well. The initial batch of components, all the caps and stuff, the Melfs all came from DigiKey. This iron tip is not really ideal for this. Yeah, and then all the other stuff has just been purchased separately. Can't really drag with this. It's not. You can see it's not flowing very well. It's not the ideal tip. It's not the ideal tip at all. I'm making this look hard compared to how it usually looks. Yeah, you can see that tip is not ideal for dragging at all. Just remove the solder from the tip. I mean, it's got, can I show you? Look, it's got a sort of wedge shape to it. It's kind of like a chisel tip, but it's not passing the heat very well. Yeah, that's not too bad, but I really don't like the shape of some of those. Ah, there's a via there, and this is the thing, is that supposed to be joined there? I don't know. And that first pin doesn't look so clever up there, does it? You can always add some more solder. Yeah, I think that goes there, look. It goes there, so that's not a problem. But that's one thing you have to be careful of on a board like this, is where you get these vias that are right next to pads. Anyway, I'm not going to clean up until we've done the next one, but that's alright actually. So let's get the next one up here. There we go, that is looking pretty immaculate, I think you'll agree. Right, my 220 microfarads have arrived. You can see it's going to be really tight here for trying to straighten that a little bit. There is no room next to the socket. Look at the pad sizing here. I can just squeeze that on there. That will just fit. It's the exact size of the pads. Well, that went sort of according to plan. It's only a few seconds later this I managed to get it on, but you can see we've had a bit of a Melf incident. Yeah. It's convenient the fact the pins are so close to each other. As I tried to solder that, then this rolled this way. So let's try and roll back that way. And do you know what? I think we've almost pulled that off, haven't we? So I'll get some flux around that, yeah, and clean it up. It looks a bit baked. I didn't heat for very long. And of course, cleaning the cap points up there is going to be pretty nearly, well, this one here, near impossible. I will use the toothbrush to do that though. Right, so I've got to watch out for the jumper. I've got to come in down here, right down there like that, and that'll do. It's fairly straight. It's not quite as straight as it was originally, but morons can't be choosers. I guess the next thing I should do here really is get the header here for the hybrid. But, hang on a minute, let's just move further to the left. I'll just move the board. We've got another cap position over here, look. And I think that's another 220, is it? I bet it is. Yeah, I need to rethink the capacitor here, and both of these are on the supply for these. We've got 220 on each one. You know, there's a hybrid here and a hybrid there. So ironically, it's on the same side on each one roughly. In fact, it's not, because I think maybe it is. They're just on the opposite side of the thing. But anyway, the point is here, trying to fit one there is a problem because of space. Trying to fit the one here is a problem because of space. There's too many of the melts around this area here. The next thing, inductors, I've got some 20 microhenries. I couldn't get 10s. 1206. The pad spacing here is huge. We've got massive pads for an inductor there, and it's a tiny little thing. So that's a thing. That's a problem. It's a problem in the fact that I didn't see current rating on this. Yeah, it will fit on the pads there because they're just big enough for 1206. But is it going to be beefy enough? I mean, it looks pretty thick. You know, it's a big sturdy thing, but it's not as big as the pad spacing. Is the point? I think that that's filtering the power to the video section. Maybe I think there's one of these for each of these. So it's whatever current is passing through that hybrid, you know, the DAC. And I reckon not a lot. So I think those are going to be fine. And I think 20 microhenry versus 10, maybe it'd be better. I don't know. As someone scientifically calculated that it needs to be 10. So if we start seeing really fuzzy, noisy video or no video at all because it burns out, we know why. And I can just reevaluate. But you don't always necessarily need to go exactly component size. But there are places where you're going to get obvious problems if you don't. And what I mean is, for example, on analog circuits here, like the audio side, the PLL stuff for the scan doubler, if you were to approximate component sizes there, well, you're going to get approximate video quality. Here, this is just filtering the supply to the DAC, so it's just a question of, is it going to be up to the job in terms of current, and is 22 microhenries versus 10 good or bad? I'm saying better. I could be wrong, because, well, there are formulas related to this stuff that may have been used as the point. Yeah, it's almost straight, isn't it? I mean, look how big the pads are compared to this. This is not what was intended to fit here, although it does say 1206. No, that's about straight as I'm going to get it. If this was supplying, you know, a large area of the board, I might just go crazy and just get solder on all the pad. Yeah, if this was supplying, say, current to one side of the board versus another side of the board, then current would be more of a concern, but I don't think so. I think this is just to filter power to go into the hybrids. So it's probably an overkill having pad size this big, but the original component may have been a much beefier type of inductor, and you can argue you get better filtering with different types. You know, this is just the chip type. If we had something that stood up with an actual coil of 10 microhenries, maybe that will improve the video. I don't know, we're just going to have to just see, suck it and see, really. There we go, that'll do. This build has really been a build of compromises. So the audio connectors, we've got an issue. Well, the first one is that Amiga Kit sent me a white one, and I needed a yellow and a red because I've already got a white. I don't know whether the other one's gone now, it's on this bench somewhere. So I've got two white ones and a red one. They didn't send me the yellow one, so that's the first thing. Then the second thing is, this is the same problem you get when you replace these on a 4000, in that they fit perfectly, yeah? And you think, oh, what could go wrong? They fit perfectly. Fit the board, what's wrong with that? And they stand further forward, yeah, by 2mm almost, yeah? So by the time you come to connect it into your case and you get your panel here, let me see if I can just align this somewhat, like that. So that's now flat with the connector, yeah? And there's a gap inside on all the other ports of a couple of millimetre. If you push it flat where it needs to go, I'll try and do it. I'll show you on the inside. Yeah, I think you can just about see the connector here. It's pointing upwards. Yeah, it's off the board, and that's not even flat. Yeah, can you see that? It's pointing straight up because it comes out too far. And if I put it there now, you can see it. If I soldered that in position there now, can you see how much further across that comes compared to this metal here? there's a couple of millimetres, 2 or 3 millimetres at least. Now on the 4000 when you fit in these, you can bend the centre pin a bit and bend these other pins so that I'll show you, it sits further back like that. Yeah, these little SMD components here mean there's no clearance to do that, so you cannot fit these new replacement ones, which is a pain. Now I always keep them, the old ones from some of the machines we've recapped and stuff in the past. So I've got a white one and a red one here, and they've cleaned them up. You could argue you should have left the original ones on, but look, they're not gold plated and they were pretty corroded at the time, but they've been cleaned a number of times, so I could fit these, and I think these might work better. I don't know, let's try one of these. Let's just test on the multimeter. Yeah, it would have been better, if you ask me, if these ports would have just been the same as the ones on the 500 plus, because I could have removed those and stuck those on, but they're not. Yeah, you see, so that centre point there doesn't connect to either of these. So, like, what is that? Are these just anchor points? Those are grounds. All three of those are grounds. Right, now it's making sense. Yeah, so your signal is the centre point there. So actually, I think, if I can find them again, I don't know what I've done with them now. Yeah, this thing. This is what we might need, because I think that this is going to provide a ground and a centre point, so we might have to go with these, as cheap as those look. Let's just see where the ground is. No, the ground is the other one. Oh, that is a problem. You know, the centre point here is going to be the ground. Oh, hang on, no, that's right. That's right. The back one is the signal. Yeah, those will do the job. Those will do the job, I think. Yeah. Right, so let me remove those, and we're going to have a go at trying to fit these on here. And yeah, as cheap and cheerful as those look, they're going to do the job, aren't they? Do you know, I forget what this came from. I'm sure I could source some brand new, like, gold-plated ones that have got the same footprint there. But anyway, I prefer to recycle everything I can, really. And let's just hope this fits. Hey, those are going to be perfect. Those are going to be perfect, I think. Yeah, just pressing that into position. It's pretty much flat here, so yeah, we'll go with those. I'm going to have to try it out in the case. I did a couple of Patreon and YouTube member exclusive videos on this, doing all sorts of different pieces and bits and pieces of this case, so if you want to see more about that, maybe consider supporting the channel. You know, each dollar makes a massive difference. Anyway, I need to take the drive out, don't I? That's the other thing. It's quite a challenge to get this in this case. You're better off removing the front panel, to be fair, before you try and get the board in and out. And right now, well, I'm not doing that, am I? Let's just try and juggle it over the points there. And look here, this is the problem. Oh my god, how are you ever supposed to get this into here? That's actually technically impossible. You got to snap this up, bend this out. Oh my goodness. Can you see the problem here? I don't know whether that's on camera. The hole is for the standoff there, but you've got to get the ports in. So it's like a chicken and egg situation. Like, how would you get the ports in there and get it over the... There you go, you've got to do that. Maybe it's easier than I'm thinking. Oh, I didn't like that. The snappy noise. What's going on here? Oh, that's that tape. But this point here now is stuck. Look, it's like the most ridiculous design ever. That is just nuts. Can we push it marginally? It's going to end in tears, this, isn't it? There we go. Well, it's in there. It's never going to come back out after that. Right, let's now rotate it round. I just want to try this out to see, is this... And look, this is the other problem now. A chicken and egg again is how would you get this in? When those have got to be below that, you've got to lift this up higher than this. Oh my god. Commodore, what were you thinking? Am I right? It's not the original board, but I suspect you'd have the original problem here. This problem with the original board is the point. could try and sort of do a bit of that, you know, like lift the board and the back of it at the same time and then try and slide it in and down. This has come out of that channel there, look. Now that's out. Right, let's have a look. Yeah, that's pressing is the word I was looking for. It's alright, but it's pressing here. Can you see? It's pressing this port away there. You know, if I was to press like that. Oh, hang on, maybe it isn't alright. I don't know. It's hard to tell. It's hard to tell. I mean, it's not soldered on that port at the moment. Yeah, you can see my absolutely terrible OAP slippers here at the moment. Yeah, I'm not really sure what's pushing this away here. Maybe I'm imagining things. Maybe it does just sit a millimetre or two away. Let's have a look at the screw mounts here. Now you see that they're not screwed in. So like this is going to push it further back when it's screwed in. You really need to screw the board in to trial this. Yeah, crisis averted. I took this off and there's still a gap. Let me show you. Yeah, as this sits in there, there is an actual gap of a millimetre or two all the way down. So if the pin profile was correct on the new connectors I've got, the ones from Amiga kit, the ones from a 4000, they would probably still fit, but they're not. I mean, alright, the pin out is wrong, isn't it, I think? Yeah, you see they don't have a centre conductor, yeah? The signal is these two here. You could join up with a wire on the underside, but you'd have to cut traces because, let me just show you, if I just pull this out of the way. Oh, I can't even do it now. You've got ground in the triangle around the outside. With these ones, the signal is these two. So you'd need to, you know, join those to the centre conductor there, one of the side ones. But then at the moment they're connected to ground, so you'd have to sever them from ground, which is a bit of a problem, isn't it, really? In the name of comedy and, well, you never know, something might happen, it might break. I've got to get this post up and get these ports out, yeah? So I don't know how to get that out. That is just ridiculous. Absolutely ridiculous. Trying to go up at a sharper angle. I feel like I'm stuck on something somewhere. Oh, it's the post at the back here. Oh god. Right, let's get the one at the back out. So I don't know if you can see that. That one at the back there, get that out first. And then you're just dealing with this, and then hopefully get the angle right. There we go, it'll come out. You can see one of the case clips has been melted on that. I had to melt that to join it back up because it broke. And I didn't break it, it was broken before it got to me. Anyway, let's get my bit of tape back on there just to hold that for the moment. Need to deal with a power switch for this. It's the other side actually, the power switches. Yeah, we're almost on knee cam here, aren't we? There's still an inductor or two to solder around here, but I can do that. I'm not going to struggle, so I'm just going to solder one point like that, and I'm just going to adjust it slightly, try and get it straight, try and get it flat. Hold it, hold it, hold it, and then do the other one. These don't even need trimming down because they've been reused. You know, they've come off that little PCB you saw me salvage them from. Hold, hold, hold. Ow, ow, ow. Getting hot. Let's just flip that over. There we go. One yellow, luminous yellow. It's really bright, that, isn't it? Connector. So that's the composite. And then it's red for right. That's the way I always remember. White for whatever. That's what the W is, white for whatever. You could stick something over those ground things there, like a ground point, you know, actual strap over the top of the connector. I mean, it might be recessed back too far to do that, I don't know. I'll sort of explain what I mean in a minute. Yeah, that's nice and flat now. It's flatter, yeah. I seem to have pulled the, you know, it nearer towards the rear connection first, which meant it was launched upwards a little bit. Now it's not. And I think that that's going to be fine. So, yeah, we've done red for right, R for R, white is whatever. Yeah, so I'll clean the solder points up off camera, but yeah, those are alright, aren't they? and just getting a tiny bit of deoxit. You can argue this is wasted on these awful connectors, but yeah, there you go, just cleaning off the awful marks that were around there. You can tell those have literally had no use at all, they're just a bit fingerprinty and oxides, I guess, sat on them. But what I was trying to explain before, because of those 2 ground points, you could put a wire over the top like that, tight, soldered on, you know, to hold at the top there to give it a bit more support. I might do that later. We'll see how these work out before I do anything like that, and we'll see if we can find some better ones before I commit to that idea as well. It might be the case we can get some gold plated ones, but we still have to have a strap over, I don't know, or we might find some gold plated ones that have the proper 4-pin footprint. It's always good at keeping things like that though, junk things like that. I thought at the time, shall I throw that away? I'm never going to use it. Well, you know what, I ended up using it, and we can take off this little S-Video mini din here. Right, so we're kind of getting ahead of ourselves here, but I'm fitting the jumpers at this stage. I just want to make sure that, well, everything's on that needs to be on. I'll be doing a power test without any of the ICs fitted here. So this pin header here, 3 pins. From what I understand, you select either these or that. I think it's a bit cryptic, the information. It was translated from German. I used Google Translate to translate the PDF anyway, so I fitted it to the right, so it's going to use one of these. So probably on our first power on we'll get diagram into one of these. Now the reason there are 2 of these, it's not for high and low. You can use a 16-bit ROM or a different one here, 4096 style, and that one there is for a 27C400 I think. And then you've got this 1 meg a byte flash ROM. We've got that, solder that on in a minute. So you can have, you know, your normal kickstart and then extended in there, and you can flash this from the machine. So we don't need to program this up before we stick it on. We can, there's some software, but that's assuming we can get it even booting. Got a long way to go yet. The jumper, where is it now? Back here is for the tick. So I think when it's in the right hand side, it's going to take V-Sync from Agnes. Now it clearly says if you're using an 8375, R75 should not be fitted. So I need to have an inspection. I don't know where R75 is. It must be underneath this maybe. Yeah, I need to find R75 and remove it, because I probably will have fitted it. And it's the same with the jumper. I don't think you fit the jumper. It might be this jumper. I'm honestly not sure. Which was that? That's S7. Yeah, I'll come back to that in a minute. Down here we've got the enable or disable IDE, I think. So I'll put one there just to over 1 pin. Oh god, I dropped the jumper on the floor. Everything goes on the floor. And from what I understand, this here is to bridge auto config. So if you've not got anything in this first slot here, it won't feed back. So you close it with this. Now, hang on, I can get that on there. The other thing it does say is, and this is where it's a bit cryptic in the bill of materials, it said NB, as if not bothered. So I'm like, well, what do we fit there? What does NB mean? Does it mean you're not bothered about the size? Does it mean don't bother fitting one? And I think it's an optional, either pull up or pull down, and I think it suggests 1.5K. I've not got 1.5K, and I don't think 1.5K is needed. You could probably fit 2K2 or something. So I'll see what I've got in the way of a resistor, and I might fit one there anyway. But anyway, that's now bridged, so that won't stop auto config working. Although there's nothing really on here, and there's another one for this slot here. Yeah, it says jumper S7. It says when the expansion is plugged in and the jumper is set, the configuration signal to the expansions are bridged. The extension is not recognised and may become corrupted. That's so cryptic what that means. When 02 slot is unused, jumper S7 must be inserted. So it's the same sort of thing, that when you're not using the 0 slot, you want to bridge that. I think that's S7. And then down here we've got another jumper, and I was wondering what this was. I wonder if it's for the light pen stuff, and it is. So this is if you're using a light pen or a mouse, presumably on that first port there. Which way does it need to be now? Let's have a look. Yeah, so it says if jumper X4 is in the upper position, the gain port is selected for the light pen. If jumper is in a lower position, the mouse port is used. So it must be the bottom one, doesn't it? So the one thing I'm not sure about here is these pads here. You've got S8 and S4, and you're supposed to bridge solder one way or the other across these, presumably to select whether you've got the 8375 or 8372B, because I think that's the same as the 8375 pin out. I could be wrong. Or the 8372A, which again there's a 2 meg version of that I think went on 3000s. So yeah, and again the manual, you know, the instructions are a wee bit cryptic. It warns you that if I think these jumpers here, if one of them's jumpered, is it those? Yeah, that's S5 and S6. I don't know, let me just read out to you what it says in the manual. Yeah, it says, when using an Agnes 8372B, the start screen can be switched between PAL, and it says jumper X17 open, and NTSC, jumper X17 closed. Where the hell's X17? I don't see an X17 anywhere. I mean, it's pointing to these in the thing, in the manual there, but those aren't marked X17, they're marked S5 and S6. Right, 20 minutes later, I'm a bit wiser and also a bit more confused. Yeah, this jumper here switches between that one and that one, I think. Doesn't switch between that one. This one is configured by these two jumpers here. I think one of them enables it. These two work in conjunction with these 4 blobs here, these 4 things, S8 and S4. Now, the schematics show that being switchable. In other words, you can jumper these or not. But they then get pulled up or pulled down, I think, by these resistors here, probably, just looking at this. And these jumpers are either on or off, so you're going to be high or low. So I think what I need to do is put a solder blob on S8, a solder blob on S4. This won't be enabled unless one of these jumpers is on. And then I think the other jumper enables the writing of this, I think. But again, it's all a little bit, well, not very well explained. It probably is if you speak German. I might just check on my Discord, because some of the guys in there do speak German, got some native German speakers. You can see them here. Yeah, sorry, that's not focus for all. S8, S4. So we've got S8 going to A25. So straight away I'm like, what's that doing? And S4 goes to ROMN. So I mean, it's shown as a switch, it's not, it's just an open contact, isn't it? And then you've also got here rolling on the floor, laughing extremely nastily. I don't know what that stands for. Ruffle. As soon as I saw that, I thought rolling on the floor, laughing. Yeah, and those come down here, and you can see you've got S5, or is that S6? I can't even see that. S5, and then the other side, S6. And each of these has a pull-up. That's R2, 124, 124, what's the other one? Oh, that one doesn't have one. That's interesting. R124, where's that? Yeah, that's the bottom one there. I'm not sure these schematics are right, because I think this one's got a pull-up as well. But you see that says FLAN, flat N, flash enable. I don't know. It's like, it doesn't help when you have these bus connections like this, because you're thinking, it's not actually those, is it? That flash enable, it just goes further up somewhere, off the page here to the flash maybe. So that's how you enable the flash, S5, which I think is the first one, is it? No, it's not, it's the second one of the jumpers. And then S6 is ROM flash enable. I don't know what that means. I mean, you've got flash enable and ROM. I don't know what the RO is. ROM flash enable. But what's flash enable do? I don't know. Let's be honest, it could be slightly better documented, couldn't it? So the question is, do I need anything as jumpers there? I don't think so. I think those are for programming and enabling that in 32-bit mode, doing something with A25, which makes sense actually thinking about it. A25, it's 1 bit up from 24, isn't it? We're out of the 24-bit range, I think. Well, I know, but how that is relevant to that I don't know. But anyway, I'm going to put a solder blob across. Should I? I don't know. This is the thing, I don't really know what to do. I guess if I don't solder blob those, then this is the thing that's a bit confusing on this. What do they get? You know, the ROM enable and the A25. Well, the A25's not getting to the LSI chip, and it's an import. Is that a good thing or a bad thing? I don't know. I think it needs to be aware of it, at least, does it? So, what would you do? Would you solder S4 across there and S8? or not? I mean, it's an import, it's not going to cause us any problem. The worst card just doesn't boot. I don't know, but these are variables that I don't like. I think we're going to assume that those and these are to do with that. So whilst I'm going to fit that, I'm not going to do anything with these just for now. We'll test it without anything being jumpered or soldered on there and just see, does it actually work? If we can get it working, then we'll start investigating further to see, can we flash this ROM? No, we can't. Let's try setting these. Can we flash it? No, yes, we can when we've got the jumpers on, etc. And we'll just do a bit of experimentation that way, really. R75 and X17, neither of those exist on here. You know what I'm wondering? I'm wondering if this is a later board that only supports an 8375 and they just did away with that. There is no R75 and there is no X17. It's the most rational explanation, because I do know from the files that Stefan sent me, there seemed to be, I think there was a Rev 0, a Rev 1, and then I think a Rev 5. Where's it say on this what this is? Oh, there's a thing down here. It says A1000 board -04. Oh, well, great. That confuses matters even more, doesn't it? So there's me with information on a 0, a 1, and a 5. No 4. What was wrong with 4? Why does 4 not exist in the documentation I've got? That could be the other thing here. This could be an in-between version where there was some fundamental issue with it. It's been fun building it. It's now getting to that point where it's getting stressful, though. The thing is, you see, this was designed and built back in 2008 or before that. The documentation I've been looking at, so I've got 2008 stamps on it. So this is, you know, you might think this is a brand new thing for the Amiga 1000. It's not. It's pretty old. It's pretty old. And there's nobody seems to have built one, really. See, if you're going to remove something from a design, put something on the silk screen. I would just have, you know, if this is like a new, I'd have X17 no longer on Rev 5, no longer needed, R75 not fitted, doesn't exist. Something along those lines, because then when you do get somebody who's like me, who's looking at older documentation for a later board, I'm not spending all year trying to find R75 and X17. Actually, because that says Agnes 8375 there, that makes me think this only works with an 8375. Maybe that was the difference between the Rev 4 and the earlier Revs, but I'm sure the schematics are based on this revision, so I don't know. So I spent a couple of hours getting more confused with this. So the older revisions of the board had a jumper up here, which was, yeah, and a resistor for the Agnes. This doesn't have this R5, and an R4. I think it's a Rev 4, it says 04 there. I've got schematics for 00, 01 and 05. None of the schematics have that chip there. All of the schematics, the first two anyway, 0 1, have the R75 and the X, is it 17 or something, you know, a jumper here to switch between Agnes. This doesn't have that. The fact it says 8375 on the silk screen instead of just Agnes makes me think this is 8375 specific. So that's fine, I think. I can live with that. Yeah, so again, the video is going on a little bit long. We are approaching the end point where we're going to be able to test it, though. In the next part, we should be able to power this on and try and get this up and running. Because most of the sockets are on there, most of the components are on there. There's just chips to install in the sockets, and some SMD parts that get fitted in the next video as well. The number of hours spent to get to this point was actually quite considerable. It's incredible how long it took me to build this. Anyway, I do hope you found the video interesting. If you'd like to support the channel, please see the Ko-fi and Patreon links down below. I'll catch you in the next video.